Hi, Spring fans. Welcome to another installment of Spring Tips. I have shown a lot of different things over the many years I've been doing these videos, and it occurred to me recently that one of the fundamental pieces about which I've spoken here, there, and elsewhere, about which I haven't fully articulated, is the concept of proxies and how they're used in the Spring ecosystem. So that's what we're going to do today, is we're going to deep dive on where Spring makes use of proxies to make it easier to decompose your application. The magic of a proxy is that it allows you to introduce behavior into an object that wasn't there in the original definition. And we do this through the magic of polymorphism. Remember, Spring is an application container, but it's also a dependency injection container. It has a bunch of objects and it knows the shape of those types of those objects in the system. And it knows that if it swaps out one instance of a thing for another instance of that same type, or at least a subclass of that type, the consumer won't know, right? It's polymorphism. It just needs to know that what it has is a foo, where foo is the type that you gave it, and it doesn't care that it's actually a subclass of foo, right? And that is a very powerful mechanism. It allows Spring to do a lot of things on your behalf by seamlessly introducing new behavior. And that's a sort of high-minded, highbrow sort of a discussion of it. But to make it clear and to make it understandable, let's deep dive, as I said, by going, as always, to our second favorite place on the internet, start.spring.io. All right, start.spring.io. We're going to call this proxies, and we're just going to bring in the GraalVM stuff. We don't really need anything else here. And we have a zip file. Let's open that up. Let's suppose we have an interface called customer service. And let's say there's a method here called create. Create what? We don't know. Who cares? Okay. And we're going to create a interface implementation customer service, right? Or maybe we call it a default customer service or something, right? And it's going to implement customer service, and the method will be create, and we're just going to call system out create. All right, very good. Now I want to introduce new behavior to this. Maybe I want to have my own transactional, right? At transactional, it's in the Spring lore. It's been there forever, right? We can use the JDBC API, for example. Add that, Command Shift I, and then go to transactional. And let's just copy and paste the definition here. Okay, so we'll go back here and we're going to create our own class called my transactional. And let's get rid of Spring's implementation. Now that we've done that, we'll just remove it from the build. Command Shift I again. Okay, so there's my new custom annotation called my transactional. And I want this method to be transactional. So I've got my own custom annotation. I know Spring already has support for this, but as a thought exercise, let's work out what it would take to support this custom annotation. Okay, so now I've got this default customer service. It has a method which we've overridden in our implementation, and it is at transactional. For now, let's not bother with wiring things up in dependency injection. Okay, and actually, you know what? Let's see. Let's call this new application runner, and we're going to create an instance of this. So we're going to call it default customer service equals new default customer service. All right, very good. And so now we have our default customer service. I want to add support for detecting and then honoring this annotation. And what this does in Spring is that when it's detected on a method, I'm simplifying because you can also put it on a class, but all that does is it applies to every method, right? But if you put it on an individual method, it tells Spring to sort of wrap the invocation of this method in a transactional boundary. So it'll start a transaction before it calls .create, and then it calls .create, and if there's an exception, it'll roll back the transaction, and if there's no exception thrown from create, it'll commit the transaction, okay? I'm not going to re-implement all that, but let's just suppose I wanted to do something sort of similar to that. How would I do that? Well, before we get into the use of proxies, let's just take a moment to think about how we would solve this with just regular old JDK primitives. One of the easiest ways might be to use the JDK proxy mechanism, right? And I can do this here. I can say new proxy instance default class loader dot get class loader, and then I need to provide an array of interfaces, right? And so the interfaces here are from the class get interfaces, right? And then finally, I can provide a new invocation handler. Okay, and this invocation handler, oh, whoops, I can't put an array of arrays. Okay, this invocation handler is a listener, it's, if you will. It's a callback that gets invoked when you call a method on the proxy. Okay, so what I mean by that is this is a customer service. I'm going to call .create. Okay, and let's see what happens here. Calling method.getName with arguments. Okay, there we are. So there's this, and then we're going to return method.invoke. And basically, this is a Java lang reflect method. We're going to call the method on the actual target object, passing in the arguments. Okay, so we're not gonna, we've got the proxy reference, but that's an implementation, and we're gonna call this method on the implementation of the proxy, or on the class that implements the same interface as the proxy, but not on the proxy itself. We're gonna use the target object here. That's this default customer that we created. So target, let's just call it that. Okay. All right, so let's try that. Let's print this out and let's just see what we get. Okay, so you can see very clearly that our proxy is in the execution chain there, right? If I call a method on the proxy instance, I cast it down to customer service, I call that method, this gets invoked, and it gets invoked for all the methods that are created by this proxy, okay? And I can do something, I can test, for example, that I can say if method dot get a class dot get annotation, right? My transactional dot class does not equal null, then system out starting transaction, okay, for this method dot get name, and I can put that over here as well, and I can say finishing or stopping or whatever, finishing transaction, and then for this, there's a results value there, and I can return the result. The result in this case is null because the method returns void, but in theory I could, right? And you might very reasonably wrap this in a try and then a finally, right? So that way it's guaranteed that you clean up the state one way or another, either committing the transaction or rolling it back if you needed to. Okay, and in fact, you could just return that in line now. Oh, you know what I just realized? If the method.getAnnotation is true. There we go. So there we go. So we started the transaction for create and we finished the transaction for create. We called add, but nothing was, there's no transaction started for add. It's not in the beginning, not in the end, right? So this is working as we expect. We have an ability to place ourselves sort of in the call chain as a listener, kind of like an event listener, right? Very, very meta programmy, but it's really powerful because now this proxy is an implementation of the interface, and I can swap out this implementation for this one, and nobody will be the wiser. And I can seamlessly introduce new behavior here, right? Okay, so what if we tried, what if we wanted to simplify this code? Well, it turns out Spring has a very convenient class called ProxyFactory. So var pf equals new ProxyFactory, and pf dot set interfaces is equal to the, it's basically the same as we did before, right? Get interfaces and pf dot set or add advice, new method interceptor. That's the AOP alliance, right? Set target, and the target is the default one there, or I guess we can just call it target, okay? And so we have the same basic opportunity here. Invocation dot get method, that's the method. Invocation get arguments, right? It's we have the method, which is a method. We have the object arguments, and we have the proxy target, but we don't need those other bits. So let's just copy and paste this code, all right? And put that in this new code. All right, so same basic thing. We can just pass in arguments instead for consistencies. I'll do that, okay? All right, and now we can just delete this existing code, okay? And we'll say var proxy instance equals dot get proxy, okay? And we want to pass in the class loader, so we can do a get class dot get class loader. All right, so, and this doesn't have a type, so let's downcast it as before to customer service and rerun once we have fixed that. Okay, same basic behavior, right? We've got now a create method, we've got a finish, starting the transaction, finishing the transaction, etc. for just the one method with the annotation on it. Now, what if I wanted to sort of introduce this behavior in a generic fashion? Okay, one way to do that would be to let's say I had some logic to look at any given object and find out if it has transactional annotations on it, right? And the way I could do that is just to write a little method here. So static Boolean transactional. Okay, so given an object, I want to test and see if it's got any methods. So I can say reflection utils dot find method o dot get class and find methods. Oh, sorry, do with methods. There you go. I can say reflection utils dot do with methods o dot get class new method callback, and I'll just create a boolean here. So has transactional, those new atomic boolean false. Okay, and we'll say if method dot get annotation my transactional dot class does not equal null, then has transactional is equal to true. Okay, and we can return has transactional dot get. Very good. So that's a very simple test to test and see if there's an annotation present on the type that we're trying to inspect. Okay, so now we've got this method. Can we use that to then make this transactional support generic? Well, yeah, because Spring gives you a chance to visit every bean in the application context. So let's suppose I made our customer service a bean. Okay, so return new default customer service, and let's get rid of this. And now I want to then take this logic and visit every single bean. And the way I can do that is by creating a my transactional bean post processor. Implements bean post processor. This is a callback interface. It's been in Spring for decades, but the contract is pretty simple. We can say if transactional bean, then we return this proxy. Okay, so the target is this bean here. So you're going to get a chance to visit every bean in the application context right before they get made live. Okay, and the contract, you can also return a different object. So you're given an object, you can inspect it as we are here, and if it matches some condition, you can return a new object instead to use and to manage in the context. Okay, and that's what we're going to do here. Okay, so there's this. Otherwise, we just punt on that. Okay, let's register this bean post processor. Okay, all right, there's that. So now let's run this and see what we get. Now, mind you, I have got no instance here, so I'll inject that here. I'll say customer service, and then we can just replace these two with that. Let's think about this. So we got this bean post processor. It's going to inspect every object. We've got a test. This test in turn looks at the methods on the class, but that's not the methods on the interface, is it? So var classes equals new array list of class collection utils dot, we'll say collection dot add all, right, classes, and then we'll pass in an array, so o dot get class dot get interfaces. And then with that done, we can say classes dot for each class, and then we'll test this, right? So we're going to say for each element in the classes, replace it with a lambda, and then if that's true, then we actually return true. So let's try it now. Okay, so that worked, right? So we are calling create with arguments, starting a transaction for create, finish transaction, calling add with arguments. There's nothing in it, but okay. And then we call add. So it didn't start a transaction for add, but it did for create. Okay, so that's working well. Very, very simple. And it's generic now. I didn't have any specific logic here to proxy that object. Very good. So this is a regular JDK proxy. Let's turn this into a native image. The problem is that we're creating a proxy and GraalVM doesn't know about proxies by default. So it's going to want to know what interfaces our proxy implements, right? So var proxy, and we can say proxy.get class.get interfaces for var system.name, okay? And so now you can see it's actually got the resulting object has 4 different interfaces. We need to tell GraalVM about that new proxy. And good thing is GraalVM actually has native support for JDK proxies as we're building here. So let's create a bean, a proxy bean factory initialization AOT processor, and let's implement this method here and just return a processor. And all we're going to do is get the hints and call the proxies method, and we're going to pass in those types like that dot class and finally like that, right? So we're just passing in we're just calling the hints method there. Okay, so now this is configured. It's going to tell GraalVM to register these hints, this hint for this new proxy that we know will exist at runtime. Let's go ahead and try it out. Okay, so we go to the target directory and call proxies. And there you go. It worked just fine, right? The application started up. You can see we have this proxy. It said starting transaction for create, called create, finished it, calling this one, but there's no proxy device, so we didn't have that. Okay, so this is all very well and good, but there are still some problems, right? First of all, what happens if I move this annotation to the method itself, right? Well, let's try that. Okay, nothing, right? The advice, the proxied method isn't visible anymore. It's not checking the concrete class, it's checking the interface. And if the interface doesn't have that annotation, then no go. Okay. And then also, speaking of that, what happens if I just get rid of that? Why do I need an interface in the first place, right? I've only got one implementation of this class called default customer service. Like, why would I bother having an interface? It makes no sense. It's bad OOP design to do that, in fact. So let's try running that now. Okay, and oh, I have to inject by the right concrete type. Okay, so let's run that now and see what we get. Okay, so that's working, right? But what happens if we get rid of the target, right? So it's not working, right? And there's a reason for this. Behind the scenes, we're getting two different kinds of targets, right? Two different kinds of proxies behind with this ProxyFactory. And so you can see we have a target here, set interfaces, set target source, etc. If it's an empty target source, then we get one kind of behavior. And if it's a regular target source, we get another. You can kind of see this in action if you dig deep into the call chain there. You can see there's something called the default AOP proxy factory, in which we have this method create AOP proxy. And behind the scenes, you can see target class is interface, or it's a proxy class, or it's a lambda class, in which case return a JDK dynamic AOP proxy. Otherwise, return one of these, right? So if the target type is an interface, we can trace down through the code and we can see that there's actually this very interesting branching here. And the most important bit is this. If it's an interface, first of all, if it doesn't have a target source, as is the case here, which is what we got, it'll just fail. But if it was an interface, if the target type was an interface, right, and you can specify the target type directly, I could say pf.set target class. If the type that we send there is, for example, customer service.class, you'll see it enter this branch here, right? But if we, in this case, want it to be a concrete type, well, then we get a different thing altogether, don't we? So let's stop this and then return over here and restart, okay? And so you can see the presence of an interface on the target is very important. One begets a JDK proxy, one begets a CGLIB proxy. And the reason is because CGLIB is the only way we have to proxy concrete types. Let's talk about that. Imagine we wanted to work with a concrete type. And forget about proxies for a second. Let's just step back and work with regular object-oriented principles. Okay, so let me move all of this out. Let's go ahead and remove as much of this as possible. So now let's imagine I wanted to introduce that new advice for a concrete class. So I'll create a bean of type default customer service, like so. Turn new default customer service. Okay, and now I want to introduce that new behavior. Well, I can do that in a post processor just as before. So let's go here, static class, my transactional bean post processor, implements bean post processor, returning that. And what am I going to return? Well, I'm going to return a subclass, aren't I? So static class, my transactional default customer service extends default customer service. And I'll override these methods. And I can detect that, create has transaction annotation on it. And so I can say starting and then stopping TX, right? So I want to tell Spring that we have a customer service it should use, but not the one that was configured. We can say if being instance of default customer service, then return this one, a subclass. Again, polymorphism for the win, okay? Take that type, static, and let's restart this. Okay, oops, I forgot to create a demo to use that thing. So application winner, okay, and then we're going to inject the default customer service there. Okay, ready. There we go. So you can see the same logic applies, right? Starting, create, and stopping. So the bean post processor allows us to do a quick swap in place and replace the bean of one type with the one that has the advice that we want to introduce. And the user of our type, the consumer, still just injects a default customer service. We're able to sort of transparently do that behind the scenes. Well, how would we do this in an automatic way, right? We can't all just, it's not really a solution to write out a new subclass each time. Well, that same ProxyFactory that we looked at earlier, that can actually create subclasses for us dynamically using bytecode generation. So it'll use a library called CGLIB, which will in turn extend another class. This is why there's a very important limitation that your classes must not be final if you expect Spring to do anything interesting with them. Okay, so let's see how that looks. Let's change our logic here. We're not going to use this anymore. And we're going to change this test here. Okay, we'll rename things to be appropriate here. And we're going to say pf.set target is equal to target. Okay, and we have to make sure that this is registered. It is, good. Let's see. We have now a method that will replace the implementation that we have with one that matches, assuming, you know, we want this to actually get done. So we still need to filter. We need to say, okay, if transactional, then use that bean, right? So let's try this. All right, transactional target. If not transactional, then we'll just return the target, and then otherwise we'll continue on to do this. Okay, so that seems to be working, right? We've successfully generified our behavior there. We are injecting the default customer service, and we are getting as a result of that, we're getting the ability to just call this method. We didn't have to provide an explicit subclass, okay? Very, very generic, very, very convenient. Now, what if I wanted to use this in GraalVM? Well, if we want to use this in GraalVM, we need to provide more information about the nature of the proxy at compile time. So let's make this just a bit more intelligent. We're going to refactor this to be a smart instantiation aware bean post processor. And then we're going to extract out most of this logic, okay? And that'll give us, we don't want the proxy itself, we want the ProxyFactory. So let's return that, and we can say ProxyFactory. And we need to be a little bit mindful of the fact that we may not have a valid target, but we'll always have a valid class. So let's rework that. So we'll say class name, okay? If target does not equal null, add that, okay? And what we're going to do is we're going to say target and then the target.getClass, pass that in there. Okay, this gives us a ProxyFactory, and then we can say get proxy implementation from the getClass.getClassLoader. Okay, so here we're going to get a proxy implementation if it's transactional, right? Only if it's transactional. What about this smart instantiation aware post processor? Well, one of the methods that it provides is a method called determine bean type. Okay, and same thing, if not transactional. And then here we want to do the same thing with the that we did before by adding a little bit of delegation or dereferencing of the class itself, right? So class, okay, class, and okay, so this is now class, and this becomes that. So we change the code here a little bit, and we say, okay, if not transactional being class, then return that. Otherwise, return this proxy. Okay, so we're going to call get proxy and then get the proxy class. And if we don't have, you know, if it's not going to have a target, but that's okay because we can just get the proxy class. Here, we'll call get class. Okay, so that should be a little bit better. Let's try this out now at runtime. Okay, so everything's still working. Got starting transaction, finishing transaction, etc. The last thing we want to do, of course, is to make sure that our proxy has a proxy target class. Let's try this at GraalVM time. Ta-da! We now have a GraalVM native image starting up in no time at all that it has a CGLib proxy. We're dynamically subclassing a new class and registering it in the class loader after the program has started, and it still works because of this integration with this smart instantiation aware bean post processor. This is an example of where Spring has taken GraalVM's capabilities and augmented it, right? So now you can do both kinds of proxies and use them with ease in your code. Now, what does this have to do with you, my friends? Well, this is the foundational layer that allows Spring to introduce new behavior for you. We talked about the polymorphic sort of way that we're able to slot in new behavior. Remember, Spring is a framework. It's open for extension, but closed for modification. It's not actually closed for modification, but the point is you don't need to change Spring to change the way it works. You can just create new objects, right, that fit a particular shape. And with this generic mechanism and these callback interfaces that Spring provides, it's very easy for you to create new objects and change the implementation of those types and still comply with the contract expected by good, solid, object-oriented programming. This mechanism is a little low level. Actually, I grant you it's very low level. Hopefully you don't have to worry about this all that much, but it is the foundation for several other things, including aspect-oriented programming. Though they both have similar strengths, it's interesting to note that they have some different weaknesses, right? If you're using JDK interface-based proxies, then the this pointer, that is to say, the thing that you call when you call this, dot is pointing to the target, not to the proxy, because the proxy wraps the target. It's a wrapper. It composes the target. And so when you call dot this on another method, and you invoke another method from within a method, that other method doesn't pass through the proxy. It doesn't pass through the advice chain established by the proxy. Whereas if you use CGLib, it could, in theory, pass through the advice chain, right? Because you'd be doing polymorphic dispatch. If I call this dot foo in this dot bar in a subclass, and this dot foo is in the superclass, I'll get that implementation. If I call this dot foo in a subclass and there's a subclass of this dot foo, there's a overridden implementation, then I'll get that implementation instead. I always get the latest one, right? Or the most recent one, whatever. So the result is that if there is a new one that has the advice introduced in it, then I'll get that one, right? It'll call super inside of that method. So this is very, very powerful. This will help you understand, hopefully, how things like, transactional work, but also, as a exercise to the reader, try and figure out how at configuration works, right? Because remember, in at configuration, one method, one bean, a provider method, can invoke the method for another and get that instance, and the invocation goes through the proxy chain, right? Because it actually does memoization. It stops you from invoking the same method over and over if the scope is just singleton. So there's some very, very powerful capabilities here. And like I say, this is the foundation for aspect-oriented programming, a topic I think that will remain for yet another day. As always, my friends, thanks for watching, and I hope you got something out of this.